In the cloud. And does it show to you, Jeff, that I'm recording?
Yes.
Okay, great. Hey, welcome everybody to the last week of the HPC user training series. It's been really fun, and it's also been quite a ride, a grind, and now this is our last meeting. And I want to thank everybody who's been coming. It's been pretty successful, and we're going to be able to, excuse me, reuse some of this material for other training activities this summer with high school students and other student interns. So we're also welcoming that opportunity. So today our presenter is Jeff Sale. He's been part of our education training, scientific research, staff for quite a while, and he's going to talk about interactive visualization using Jupyter notebooks and other tools on Expanse. So this should be really fun, and hopefully you guys will be able to take advantage of the technologies he reviews. What I'm also going to ask you guys is we'll have a survey coming out in the next few days, and if you could take time to respond to it, I'd really appreciate it. So we can figure out what was good, what needs to be improved, and an important question will be: is there a better day of the week, like a Wednesday afternoon? I think so, giving up our Fridays for 12 weeks in a row, it's really tough on everybody. So I'm looking for other days. So anyway, with that, I'm going to turn it over to Jeff. I'm going to stop sharing, and you may have the comm, and we'll get going on visualization, and I'll do the admitting.
Okay, thanks, Mary. I will get my slides going here. Okay, thanks everybody for joining. This has been a great series. I hope it goes as well for me as it's gone for the previous presenters. I'll be presenting on a very specific part of data visualization using Jupyter Notebooks and Matplotlib and the Bokeh visualization tool. But I will be brave enough to venture into demonstrating HoloViews and Data Shader, which are two tools developed sort of in tandem with Bokeh to work on massively large data sets. One of the limitations, which is kind of a disappointment with me, is that the focus is really on either two-dimensional data or two-dimensional data that changes in time. There's not going to be any real three-dimensional data visualization demonstrations in this presentation, and my love is three-dimensional visualization, so I won't be showing you some of the stuff that I really like. Maybe save that for another time, but the interactive tools that I am going to show you are pretty impressive, and I hope if you're not already familiar with them that you'll find them useful. I'd like to ask, actually, does anyone have any experience with Bokeh? It's a very peculiar word. Apparently, it's the term used to describe the blurred lighting in the background of a photograph. And not being a professional photographer, I'm not sure if that's very accurate. I see Dario does have a tiny bit of experience. So, okay, well, if anybody catches me being wrong about something, don't hesitate to point it out. I'm still learning, in particular with HoloViews and Data Shader. So I won't be really showing you anything that I've done with those applications, but I have some experience using Bokeh, and so I'm going to start off the presentation focusing on those applications that are fairly practical. Okay, but first, the gratuitous slide presentation. So yes, and I'm using the wrong computer. So I'm sharing two computers because I've got all my good files.
I was going to say your slides aren't
laptop.
clicking.
They aren't advancing.
No.
Okay, and I like to start off with a nice, my happy place, I guess. This is where I'm hopefully going to be sometime this summer. Okay, I'd also like to acknowledge a few folks, including Mary. Chris Myers. I had co-developed a data science with Python tutorial that is hosted on the Cornell Virtual Workshop, and the link's down there at the bottom. And Chris gets a lot of credit for educating me on a lot of the features that Python offers with Matplotlib. And then Susan Maringer, my supervisor at Exceed, and then Kate Starbird and Jen Zymeke helped work with me on some Twitter data visualization that I'll be demonstrating as well. And of course, Mary Thomas and Bob Sinkovitz are, I think, helping oversee a lot of the work that I'm doing. So I'm grateful for that. And also, so here's the links to the data science or Python for data science tutorial. I also wanted to back up here and point out, I'm blocking, yeah, this should be, I'm gonna move this. It's not moving, there we go. I'm gonna move it up there. So there's the URL for the repository, and I'm gonna escape out
Jeff,
here.
somebody's asking you to post those in the chat.
I am going to do that.
Thank you.
Yes. And this will, I think, get you pretty much everything that you need. Oh, I didn't want to stop share. Sorry, but let me post the chat. Okay, there's the repository where you can download most of the files that I'll be presenting. The other resources you'll access just by doing a clone. And once you get the slide presentation from the repository, which is part of that repository, so as soon as you get that downloaded, you can look up some of these links from the slides. Okay, there we go. Now, I'm not going to be doing this right now. I've already installed HoloViews and Bokeh and Data Shader on Expanse. And I've already cloned the repositories for HoloViews and Data Shader. In the instructions on the HoloViews website, they recommend you just install the examples, but if you just install the examples, you don't get the user guide, and the user guide has a rich collection of Jupyter notebooks that provide some added, valuable information on how to run HoloViews and Data Shader. So I recommend downloading or cloning the entire repositories. And then when we reach the point, I'm going to actually try to do a live demo on Expanse. And now Expanse, the best way to launch Jupyter Notebooks on Expanse is to use this command at the bottom here, /cm/shared, etc. And of course, you'd add your account. In this case, I'm guessing most people as part of this training series have SDS 173. Is that right, Mary? That could be whatever account you have on Expanse is what you'll put in there. Yeah. And then the data that I'm going to be using for this presentation, you can download if you just do a wget in your Expanse directory. You can get at that zip file. It's about a 200 megabyte file, but it's got all the data you need for the demonstrations that I'm going to be showing you. I didn't put it up on the GitHub repository because there are limits on what you can do. But actually, one of my REHS students, candidates, was pointing out that there's a way you can put gigabytes up on GitHub. So anybody out there who knows how to do that, I am not one of them yet. So anyway, we're focusing on Jupyter Notebooks. Jupyter Notebooks provide a level of interactivity that is really nice compared to the usual types of Python applications that we're typically familiar with. So it's really nice to be able to spin up a Jupyter server and run all of these applications in a browser. It does come with some overhead, and sometimes it feels a little bit like a house of cards. If you can't get something to work, sometimes troubleshooting can be a challenge. But as probably most of you already know, there is sort of a menagerie to the Jupyter development environment, including Ipython notebooks and Ruby notebooks and Julia. And there are multiple visualization tools that are sort of aligned with the Jupyter menagerie, including Bokeh, but also Plotly and Lightning. So I might demo a couple of examples of Plotly very briefly that come with the HoloView gallery, but we will be focusing primarily on Bokeh. And to try to put these applications in the context of the broader Python visualization landscape, you can see, if I move my mouse here, here's Matplotlib, which is really the core of all of the Python visualization tools and libraries that are out there. And then we have Bokeh here, which is JavaScript based. And HoloViews is up here, which has either a Matplotlib or a Bokeh backend. And when I do some of the HoloView demonstrations, you'll see how they kind of go back and forth between using Bokeh or Matplotlib as the backend renderer. I will also be showing you a couple of simple examples of Seaborn, but Seaborn doesn't have the kind of interface to HoloViews that Bokeh has. And as you can see, there's several other applications that we won't even be delving into. I should point out NetworkX. NetworkX does include graph visualization, but I'll be actually demonstrating how Bokeh can work with NetworkX to create some interactive graph visualizations, because NetworkX's visualizations typically are static, either PNGs or SVGs. Okay, so moving on. So yes, Bokeh, visualization library with the JavaScript backend, and JavaScript provides all the capabilities to do these visualizations in a web browser. And in the previous time I gave this presentation, I did cover Seaborn in greater detail. I'm not going to do that, but I do include a couple of lessons that go into greater detail that are, one of which is included in the Cornell Virtual Workshop tutorials. So I want to give Chris Myers a shout out for the tutorials on Seaborn. Seaborn's real powerful, but it just doesn't have the interface to the HoloViews and data shader capabilities. And speaking of which, this is sort of the HoloViz pipeline. So we're going to be focusing initially on using Bokeh with Matplotlib. And then I'll just do some simple demonstrations of HoloViews without the data shader engine running in between. We won't be using massively large data sets initially. We'll just see how HoloViews works with Bokeh to create some interactivity. And then I'll close with just some simple demonstrations of data shader. All of these are demonstrations that come with the examples from the Git repositories. Now, Exceed offers multiple ways of running Jupyter. Obviously, Expanse is what I'm going to be demonstrating. The TAC visualization portal also offers Jupyter notebooks as a capability. You'll need an allocation on the TAC Viz portal to access the notebooks there. And Bridges 2 also has capabilities for running Jupyter notebooks as well. I won't be demonstrating that either. And once again, here's the script command to run the Galileo shell script that launches the Jupyter notebook. So it grabs a compute node and then gives you options for setting the numbers of nodes and the amount of memory. I've already got one running in the background, but I've just selected one node and 8 gigs of memory. And then the default Conda environment is the base when you've installed Miniconda. So I am making assumptions that you may have Miniconda installed already. That may not be a safe assumption. But Mary, I'm sure you're keeping track of the chat if you need to interrupt me at any point.
I am. I will do that if I need to.
Okay, great. And I'm not going to go into really any detail on the fundamental principles of visualization. There's excellent visualization tutorials out there. Amit Chiragia, the director of SDSC's Viz services, has some great tutorials. And so I've provided a link here where you can check out some of the work that he's done. He gets right down into fundamentals, and so we really don't have time to go into great detail. This is more a practical, hands-on approach to visualization where the fundamental principles are sort of implicit in the examples that I'll be demonstrating. And then my first love is hyperglyph visualization. I might claim to have coined the term hyperglyph. If you're curious about what that means, we won't be going into great detail, or any detail, on what hyperglyphs are, but there is some analog with the data shader in that hyperglyph visualizations use a tool that a friend of mine had developed that renders massive amounts of three-dimensional data visualization, very complex, unconventional, unstructured types of data. And I'll show you a couple of examples of that, time permitting. But with that, I'm going to jump right into my hands-on demonstration and talk about what these tools are as we're going through them. So let's shuffle to my browser here. Okay, so actually I'm going to toggle to the SSH window just to give you a sense of what I did to launch this script. And I should probably enlarge my font here. Let's see if we got that here. Yeah, there it is. Okay, so I'll go a little bit bigger here. Okay, so to run the script that launches the Jupyter server and the notebook is on the command line there at the bottom of the screen. And that's all there is to it. Once that's run, the script automatically opens up a Jupyter notebook in your default browser. And then it gives you this URL that you'll just copy into the buffer and paste it into the browser. Oh yeah, so it doesn't automatically launch the browser window. You'll need to manually copy that and paste it into the browser. And then you'll get the directory listing of your home directory, which in this case is right there. Now I'm keeping everything in my Python subdirectory. And the first thing that I'm going to demonstrate are the files that come with that GitHub repository that I pasted into the chat. So before we get into Bokeh, I wanted to show a little example of the kind of interactivity that's available through what are called Ipython widgets. They still work. They're still fairly functional. And this is a pretty simple example. I'm going to go ahead and just run all the cells all at once in this example, and hopefully they're going to cooperate and run. It looks like they're behaving. Okay, so we'll scroll back up to the top. So I'm going to go full screen here. Okay, so the first thing we did was import the Ipi widgets as the widgets object, and then start issuing commands. One of the most common types of widgets is a slider, where you're sliding the slider and updating a number. You can also close that widget, which I've done here. So if I run one to open a widget and then run the next cell, it'll automatically close that. And then here's an example of when you run the widget and it's set to a particular value. And that value shows up in the following cell. And here's an example of displaying text in a particular cell. I probably shouldn't have run these in advance. Here's an example of sliding a slider and updating text in a text box. Floating sliders, and drop-down menus. and a drop-down menu that will update on change. So the text down here updates the text string as I select different options in the drop-down menu. You can also embed images, have a clickable button. You can have an audio playback controller that actually, in this particular example, we're not playing any audio. Start and end date pickers. So if I run this and set the variables start date and end date to the values of the date pickers, then it should give me those dates. And then we've got color pickers. Tabs. And then layouts that allow you to include multiple graphic objects like videos. So these are just some embedded videos. And in fact, they're generated from these cells down here. So if I were to clear this cell, let's go ahead and clear this. And then I run these next three cells, it will, actually I gotta redefine that out. It defines an out object, and then as I run the subsequent cells, they place those videos in the out object defined in the cell above. Okay, so that's it with Ipi widgets. I did actually use the drop-down menu widget in the next example that I'm going to show. Let's exit out here. And okay, so this example, it uses weather data that was collected from a series of weather stations distributed throughout San Diego County. And we're just plotting weather as time series. We'll be plotting 4 different weather parameters: temperature, humidity, wind speed, and wind direction. And I'm just gonna, I'll step through. Running cells in advance isn't necessarily the best idea. So the first thing we're going to do is read the data in. We're reading a CSV file into a Pandas data frame. And then we'll look at the first 5 rows. There's a column ID, which we're going to drop. And then we'll review those 5 rows just to confirm. So the first thing we're going to do is just do a simple plot. Because this is a data frame with the time series. Oh, I didn't, I kind of went right by that. When I read this Pandas, this CSV file into the Pandas data frame, I'm specifying the index to be column 1, which in the case of the CSV is the timestamp. And then we're making sure we parse the dates as a date variable. So by doing that, when we just generate a simple plot like this, it will automatically use the timestamp as the x-axis. But that's a pretty small plot, so let's keep going and resize it to make it 20 by 5 units. We can also create a subplot. In this case, we'll do a similar kind of plot, but 4 different ones for the 4 different weather parameters. And we're going to color them differently. We're also going to set the title and the y-axis separately. And we're going to color those to correspond with the color of the plots as well. And then the subplot command here is what allows us to specify the number of rows, which is 4, and the number of columns, which is just 1. And when we do that, we get this as a result. And so right now we're just working with Matplotlib. We haven't done any Bokeh, so I'm showing you some of the basics of what's capable with Matplotlib working with Pandas. In this next example, we're going to distribute them in a slightly different way, 2 rows and 2 columns. So really the only difference is just the subplots parameters. Now we're going to read the same data set in, but a little differently. We're not going to specify the index column, but we are going to make sure we parse the dates. And we're doing this so we can extract subsets of columns to create individual plots as data frames. So there's the data frame, and now we're going to create a new data frame by extracting the timestamp and the humidity columns. And there's that. Now when we go ahead and plot this, we get a similar kind of plot that we got before, but the x-axis is not the timestamp. We're going to have to call explicitly to use the particular timestamp column as a date. And so that's what we're doing here. Now we've got a date with the date label and the timestamps on the x-axis. But that's great, but we've got a static image. Now we can right click and save this if we want to. There are also capabilities of saving. So I have issued the save fig command and saved this image into an images subdirectory. But we're limited in what else we can do. We can't pan or zoom, and that's where Bokeh comes in. So next we're going to go ahead and create just a real simple example, very similar to what we were just doing with Matplotlib, using the same Pandas data frame. And I'm going to control scroll and enlarge this just a little bit. Maybe that's a little too much. There we go. Okay, so the first thing, this is now a Bokeh, interactive Bokeh plot. First thing we notice is this toolbar along the right with multiple different options. We can pan, which is grabbing and moving the plot back and forth or up and down. We can click and drag and zoom in on an area. We can use the mouse scroll wheel to zoom in and out. We can also use the mouse scroll wheel and hover over the x-axis to collapse or expand. And we can do the same thing with the y-axis. And we can save that as a PNG. We can reset the image back to its original state. And there's a nice little help icon if you're uncertain what else you're able to do. Okay, that's great. But once again, the x-axis isn't quite what we're looking for. So let's change that and call out the x-axis type to be explicitly a date time. So now we've got date by day. And if we activate the mouse scroll wheel and scroll along here, you can see it refines to hours and so on. Okay, so now let's create a combined plot similar to what we did with Matplotlib, but with Bokeh. And so now we've got 4 plots. We've got a single column and 4 figures aligned in a single column. And we can do all the same kinds of interactivities, such as scrolling in and out, or scrolling, hovering over the axes, panning, in any one of the 4. But it would be nice if we could lock them so they all pan and zoom together. So let's give that a try. To do that, we use a variable called x range. So we defined the subsequent second, third, and fourth plots to use the x range of the very first plot. And so when we run this, and now we pan, and all 4 plots move together. And when we use the mouse scroll wheel on the x-axis, it will zoom all four at the same time as well, but not so on the y-axis. It will only change that particular plot. And so in this next example, I'm going to be using a drop-down widget so we can create Matplotlib plots similar to the one we created earlier, but we'll automatically update it by selecting a different object in the drop-down menu. Okay, so I'm going to scroll back a little bit here. Okay, so here's the drop-down menu, and if I select a different weather station, we'll get that plot. And now let's change that to something else. Oh, actually, it plotted it down here. Okay, that was unexpected. It seems to be appending the plot. Okay, I'm not sure I intended that, but okay. Now let's try the same thing with Bokeh. And here we're locking the plots the same way we did just a minute ago. And then we'll update this. Okay, well, that's not the behavior I recall it doing, appending the plots on the end, so I'm not really sure I have a good explanation for why that's happening. I'm certain if I were to clear that cell, then I would be fine. So if we clear that cell, we can then rerun it and then choose a different plot. But no, it's not going to give me really what I want, though. Okay. But anyway, I'll move on to the next set of lessons. But this gives you some idea of the basic plotting capabilities, coloring the plots, labeling the axes, linking multiple plots together, creating subplots, and so on. So this next example is going to use Twitter data to do visualizations. Once again, initially just using Matplotlib to sort of demonstrate its limitations, its capabilities and its limitations, and then moving on to Bokeh to allow for deeper exploration in ways that just aren't possible with Matplotlib. So I'm not sure if I've run everything in this. Yes, I think I have. So I'm going to go ahead and start off. So this is a data set that was collected by doing a Twitter search using the Twitter streaming API on the hashtag climate change, I believe. Oh no, actually this is for hashtag Mueller report. So it's about a couple of years old. The file's available in the data that you've downloaded. Looking at the data, it includes the basics of what comes with a standard tweet ID, the date the tweet was created at, the description of the user, the user's screen name, user ID, and the actual the tweet content, which I think is here at the very end. But we're going to do visualizations of the timeline of individual tweets. So this particular notebook goes through and does some processing to extract out the top, I think the top 20 tweets in this data set. So it's a data set of hundreds of thousands of tweets. Some of the tweets were retweeted thousands of times. And so we're going to be visualizing those tweets with Matplotlib initially. So I think this first visualization is of the entire data set. So this is just creating a simple time series. I think it's actually using a scatter plot using Matplotlib. So we're importing Matplotlib as the PLT object. And here we're also doing things like enabling the grid and saving it to a subdirectory as a PNG file. And so the lifetime of this particular tweet went from early April in 2019 to late April, most of April. And it really, or actually, this is the entire data set. So the hashtag Mueller report wasn't showing any activity until the day the report came out. And then there was a lot of activity. These dips represent nighttime, which are lulls in activity in a particular hashtag's lifetime, I suppose. So it's not surprising that at night in most of the world, the activity drops. And I think most of the activity for these tweets were in North America. Okay, so these are called binned plots. They represent the tweet activity every 5 minutes, the tweet count every 5 minutes. So if we are plotting individual tweets, and that's what these plots are, the activity is a little different, but it always starts off very high and then exponentially decays. Then maybe the next day it has a little bit of a new life and then decays ultimately to die out. Now we want to know more about these tweets. And that's where we'll get into Bokeh. But Matplotlib has some nice built-in capabilities of being able to plot multiple plots and automatically introduce multiple colors to differentiate the individual time series. Now this next example is what we describe as a cumulative plot. It also uses scatter plots. And if I right click and open one of these images, you can scroll in. So these are the lifetime of tweets retweeting, but for each retweet, we add a point. So early on when this tweet was originally tweeted, there were a large number of tweets that were retweeted early on, but ultimately it plateaued and then died out over time, over the next couple of weeks. It would be nice to know exactly, some information about these tweets. Now we can change some of the information about these tweets by plotting the individual retweets to be represented by a circle corresponding to the number of followers that person has who retweeted this tweet. So you'll see these larger circles here because those particular retweets were by a person who has a large follower base. There's another example where a tweet was retweeted by somebody who has an incredibly large number of followers, which sort of gave the tweet a new life and had a large number of retweets immediately following that. So it would be nice to know things like who was it that retweeted that tweet at that particular point. Matplotlib doesn't give you that kind of capability. Okay, I'm going to move past this. So let's see what we can do with Bokeh. Now, one of the things that I'd done with this data set is I had run some bot detection algorithms on the data set to try to find which users seem to be bots who were retweeting tweets much more frequently than other users who are not bots. So if we step through here, we give the tweets, oh, what's going on here? Oh dear, okay, well, I'm just gonna, well, actually, I think what I'm gonna have to do here is move and just bring those files up. Okay. So I think what was the problem was I can't find the file that I needed to load, and I had run these scripts early and thought I had checked them, but I'll make sure I figure that out. Anyway, if that error hadn't been generated, it would generate these HTML files. If we look at the code, let me bring that code back up. We have the capability of either outputting an HTML file, Bokeh will save in the form of HTML or as a PNG. So I have a parameter that specifies whether to plot as an HTML or as a PNG. And in this case, I was plotting as an HTML, which gives me a lot, it gives me all of the bokeh interactivity. So I can pan and zoom, enable the mouse wheel zoom. And then Bokeh also offers the capability of displaying metadata when you hover the cursor over the mouse. So this is the user that had a lot of followers that had retweeted this particular tweet. Now the tweet is an original tweet of Representative Doug Collins, something about Attorney General Barr. Donald Trump retweeted it on April 20th. And it kind of got a new life. So it's kind of takes off vertically because a massive number of his followers, some of whom are probably bots, went ahead and retweeted that. So it's nice to have this kind of metadata capability where you just hover over the objects. I'm also capable of color coding it and changing the alpha transparency. So if we look at the code, I'm setting the fill color. And I'm not going to go into great detail on all of the details of specifying the parameters for making this visualization. I do want to point out though, with Bokeh, you will define a tools variable for all of the different tools that you want to incorporate into the toolbar. So I'm adding quite a few here. Most of the default examples don't incorporate this many tools, but there's a large selection of tools to choose from. And I'm going to leave, well, I think when I'm done, I'm gonna have to go back and make sure we don't generate that error. That data directory, let's see, where is that data directory? I think yeah, it should have been there, but I guess it's not. Oh, somebody in the chat, import pandas. Okay, so when I had given this webinar previously, I think it was about a year ago, I did cover Seaborn. Seaborn is a nice visualization tool, and I'd like to just show you very briefly a couple of the things that it is capable of. And this is also a really nice lesson. This is a lesson that is actually hosted on the Cornell Virtual Workshop. And this is the accompanying Jupyter notebook that comes with it. And Chris Myers really is the primary author behind this, and he does a great treatment of how to use SQLite and as a MySQL database to process the data and make it easy to visualize. And I think I've already run this. And this actually ran pretty quickly on Expanse. I was surprised. So this plot in particular, I'm going to scroll and zoom out. I need to go full screen as well. So this is what's called a pairs plot in Seaborn. And without going into really sufficient detail, this shows the entire history of baseball batting statistics for batters who, you know, in batting in baseball, if you know baseball, you can hit singles, doubles, triples, home runs, you can get walks, and you can strike out. So each one of these rows and columns corresponds, and I'll scroll in here so you can see this. Oops, too far. There we go. So the labels along the left here are first base, which is a single, second base double, triple, home run, strikeouts, walks, runs, and RBIs. And it's the same along the bottom. So essentially, this plot is a mirror image. So you really only need half of these plots, but a pair plot plots all of them, whether you need them or not. And then the diagonal is unique and shows other types of distributions of overall batting. But this is a fast way of visually seeing correlations between things. If you know baseball, you know that baseball hitters who were good at hitting home runs also struck out a lot. So you might expect to see a positive correlation between strikeouts and home runs. And so on the vertical axis, here's the strikeouts. On the horizontal axis, here's the home runs. And yeah, there's quite a distinct linear correlation between those two. And there's also a nice feature of being able to use color coding to differentiate the different centuries, or in this case, I think every 5 years. Unfortunately, though, there's no hovering capabilities. Seaborn doesn't have that kind of interactive capabilities. Now, this is an example of using Seaborn's heat map visualization, and it's a very simple single line command to generate this heat map, which shows something very, very similar to what we were just looking at. It's a mirror image, once again. The axis there is sort of the axis of symmetry, the diagonal. And so it's a quick way of seeing high positive and negative correlations between batting statistics. Okay, so you might find that very interesting. And you know, if you step through the different lessons, it shows a lot of really nice analytics capabilities that come with Python. Okay. Now, the last thing that I'm going to show you, and I should mention that there's another nice Seaborn tutorial, this lesson 5, but I'm not going to go into detail on that one. But you might want to check that one out. It shows you how to work with color palettes and generate heat maps of weather data as well. But the last thing I'm going to show you as far as the Bokeh demonstration is in doing visualizations of graphs. And it's nothing fancy. Very simple and straightforward. We're using Pandas and Bokeh and NetworkX to visualize Twitter social networks. So this data set was created by scraping Twitter feeds for the hashtag climate change. And so the nodes in the visualizations will be of users who probably had some relationship with climate change, as we'll see. So we're importing a file, an adjacency list, and you'll find it interesting to look at that CSV file if you get the chance. There's 3 columns. There's a source column and a target column, and the weight, sort of the degree of activity between the source and the target. The values in the source and target are the usernames of the Twitter accounts that retweeted these, or the tweeted tweets with the hashtag climate change. And the value of the weight corresponds to, it's proportional to the number of retweets between those 2 users. And if we carry on. So this example is a visualization that NetworkX does. It's a built-in visualization capability that comes with NetworkX. And I think I'm just going to try control scrolling so we can, oh no, that's right. It's control scrolling is not going to work here. So, and it doesn't let me open the image in a new tab. So I think I had this open, well, I'm going to download this and open it. I meant to have it open earlier. I just want to show you how it's got labels. It's a very high resolution image. I think it's about 8,000 by 8,000 pixels. And it took about 5 minutes to render on my laptop. I haven't tried rendering it on Expanse, but I wanted to keep it sort of cached in the Jupyter notebook so I didn't have to render it. But I do want to at least show it to you. So if we're zoomed in, you can see each one of these nodes has a text label corresponding to the username of that Twitter account. If we're zoomed out to view the whole image, you can't make heads or tails. And even if we're zoomed in to some of these areas, you can't see any of those names in the groupings where there's a lot of sort of plot overlap. So that's one of the nice capabilities of Bokeh, which is what I'm going to demonstrate. And that is being able to zoom in and zoom out and hover and get metadata. Now this does take a few seconds to generate. Typically, if it's not running on Expanse, it will open up a new tab and load the file. I'm not sure if it's going to do that here. And there we go. Okay, so it's rendered, but it didn't open the file automatically. So that should be in a Bokeh subdirectory named Climate Change Interactive Graph. So let's go in there. There it is right there. Yeah, it's just saved seconds ago. And here it is. Okay, so it's a similar graph. I'm not scaling the edges or the node sizes in any particular way, but we do have the capability of generating metadata to show us who these particular users are. So if I enable the mouse scroll wheel, I can zoom in here and we can see that there's two very distinct clusters. Oops, I didn't mean to do that. Let's reset this and zoom in there again. So the center of one of these clusters is a Twitter account, Paul E. Dawson. He's a climate change scientist. Some of you may be familiar with his name. Likewise, for this node down here, this is a UN climate change committee as well. So it's nice to have this kind of interactivity, and Bokeh provides that. We can also save that as a PNG file as well. Now, in this final script, I show you how you can actually modify the weights of the edges between the individual nodes. Okay. Okay, so it's top of the hour. I'm going to jump into HoloViews and just show you a few examples of what HoloViews is capable of. So the vision behind HoloViews is that Bokeh itself, even though it does have some interactivity, is limited in the kinds of interactivity that it's capable of. So if you clone the entire HoloViews, oh, I see somebody, there's a message in the chat. Does Bokeh support 3D plots? I don't think so. I should know that off the top of my head. I've not used Bokeh to do 3D visualization, and I recall looking into that, and I don't think it does. But I can confirm that if we go to the Bokeh website and look at their gallery. But no, I don't think it does. Now, Plotly does, and I can show you examples of that in just a moment. Okay, so one of the nice things with the HoloViews repository is, didn't mean to go into there, we want to go into examples. Is inside examples, they've not only got some getting started lessons, 5 individual Jupyter notebooks to get you started, but there's references to some of the different capabilities and the user guide. So there's a lot that I'm not even going to be able to touch on that is covered to significant extent in the user guide. So there's 17 individual lessons in the user guide, and then some supplementary notebooks to drill down further. I'm just going to focus on the getting started files, and really the introduction goes into really the most useful detail on what HoloViews is all about. One of the most important things is it's sort of a wrapper around either Matplotlib or Bokeh. The most interactivity is capable by wrapping around Bokeh, but HoloView provides some nice interactivity with either. And it uses what it refers to are entities. So it calls, or I'm sorry, elements. And elements is just a term it uses to describe different methods for visualizing data. So it's kind of like a scatter plot is an element, a bar chart is an element, and so on. Okay, so I think I've run this already. So the sample data sets in this example, there are two different data sets. It's of data from New York City subway stations and the activity and the services provided in those subway stations. The first data set is a tabular data set that consists of subway station names and the latitudes and longitudes. And I think there's only about 60 subway stations. So the first visualization is just of a simple scatter plot of the services available at the individual stations and the ridership that was observed. Different types of services. I don't think this lesson actually goes into great detail as to what those services are, but there are some of the names of the services as well. And then ridership is a floating point number. So here's a simple scatter plot. One thing HoloViews is capable of is defining an object called a layout, where it combines multiple types of elements. So in this case, we've got a scatter plot and a bar chart plotted within a particular layout. And it does this, it's already defined the scatter plot in the previous cell. So scatter is now an object, and you can print it and see that it's got definitions consisting of services and ridership. So we're going to continue to use that and then merge it into a layout with this new plot. Okay, did you guys? Do you guys hear me?
Yes, I can hear you and I can see you.
Okay, I'm not sure if I lost volume. I'm listening to myself in a different computer, but I'm not.
Everything looks good.
Down. Yeah, hold on a second. I'll try to reconnect.
Okay. Yeah, you're no longer sharing.
Okay, yeah, so you can still hear me. And so I'm gonna have to try to reconnect with the computer that I was sharing. So give me just a moment here.
So these data sets, some of them are modest size, like a few hundred megabytes.
Yeah, they don't get really big until we get to data shader. Oh dear. Okay.
You want me to pause the recording for a moment while you get this sorted out?
Yeah.
Through what you're doing.
Yeah. So I'm going to rerun a server. You know, I probably already have one actually, but I don't have the URL cached. So I'm going to rerun a re-request a Jupyter server and copy this URL.
Notice that's HTTPS. I'll add in the comment that by default, Jupyter notebooks do not run with a secure HTTPS connection. And this is effectively a password into your account. So don't share that connection and use our Galileo script. So it's a secure HTTPS connection. And now we're waiting to get the queue. The job's in the queue. Now it's running and it's getting mapped to the proxy server, which will make that HTTPS connection connect to the notebook that's running on a compute node on Expanse.
Yeah, and it's always been pretty fast. Usually it only takes a couple of those cycles. Oh, famous last words.
Yep, it's a live demo.
Yep. There we go. Excuse me. Okay, so now I just want to show you a couple of things about HoloViews and then Data Shader, and we will move on. So let's see here. Okay, I'm gonna run everything. So I was talking about the scatter plot, but the most important things that they're emphasizing, they can create compositional layouts where they combine multiple plots into a single layout. But in the next examples, they're taking this scatter plot. It's not the scatter plot, but it's the data that was used to render the scatter plot. But they're using the latitude and longitudes from that same tabular data to overlay it onto this image of Manhattan Island. Now, one of the things I find a little bit peculiar with this visualization is they're using blue dots for the scatter plot. So I couldn't see the scatter plots. They're supposed to be in this right image here. The only way you can really see that is, thanks to Bokeh, we can click and drag and zoom in closer and closer to the point where you can actually start seeing dots. See that dot right there? That's not in the image on the left. That is the overlaid data onto a rasterized image. We can reset that back. Okay, so I think what they probably should have done is rendered that scatter plot with a different color, which I do down here further in a place where it's a little bit more obvious to do. But here's an example of using the interactivity of HoloViews to step through the third temporal dimension of this data. And it's data of activity, subway activity on Manhattan Island over the course of 24 hours. So as I'm sliding the slider, it's rendering additional, taxi drop-off data. Now, there's also the capability of extracting subsets in the form of time slices. So these are different times from the data set, same kind of data. But I think it was down, yes, it's down here where I actually, no, it wasn't. Yeah, right here. Instead of using deep sky blue, if we use red, there we go. So now, depending on the hour, the point of this visualization is to single out the subway stations in the areas where the taxi drop-offs were the highest frequency. And so I don't necessarily need to zoom in to see those now. I've colored them a different color. But this provides a demonstration of how to use overlays, compositional overlays in HoloViews, and then a little interactivity. Now I forget what hour the activity was at its peak, but you get the idea. Okay, so that's one example of HoloViews interactive capabilities. And then you can also save these as HTML files. So if we look here in our directory, we see one right there that has this interactive slider capability. So you can make these interactivities available on your website as an HTML file, and that's nice. Okay, so the last thing I want to show you, really, the second, third, and fourth lessons are pretty good too, but I want to show you this one because we don't have a whole lot of time, and I don't want to take up the entire 2 hours. But this is a demonstration of how HoloViews uses live data from the server to update Bokeh plot. And I think I've already got this going. I think it's this plot down here. So let me run this. Is it going to work? No, okay, so I'm gonna have to start from the beginning and run everything. Okay, so this is just a computational model, a nonlinear model that's got a phase portrait plotted where there's some interactivity defined where you can adjust the parameters in phase space. So this initial plot is just a simple bokeh plot. And then we do some live parameter exploration. Okay, yeah, so that's this. So this is a GIF animation that the lesson included. This is not a real interactive component. You'll have to run the cell to get the interactivity. But now we've got these sliders here that will change the parameters to render a different phase portrait. But what's especially nice, if we, want to make sure I keep running here. We keep coming down here. So here's an example in which I'm hovering the mouse over the plot, and it's updating the plot based on where my cursor is. And it gives me a line pointing in the direction of, I'm not sure if you'd call it entropy. I think it may be the slope of the particular surface there. And we've also got sliders that we can adjust the parameters with as well. So this is a way of using, this is assuming that you've got a Python server feeding the data to this plot interactively and updating interactively. Okay, so I'd like to show more about HoloViews, but I want to jump to Data Shader just to give you a sense of what its capabilities are, and maybe in some ways its shortcomings. So Data Shader is designed to aggregate massive amounts of data into rasterized images, which is really just a bitmap image. So it's got a highly efficient way of reducing millions and billions of data elements into a bitmap image. But the fact that it depends primarily on bitmap images is kind of a shortcoming in my opinion. But let's look at this first example, because this is pretty impressive. So it turns large data sets into images, preserving the distribution in a sense. So this first example is really just a bitmap image of the taxi drop-off data that we were looking at in the previous HoloViews example. It's just color-coded slightly differently. And this consists of, I think, 10 million data points. And if we run this cell, then we get a bokeh plot that uses HoloViews to overlay the data set of the taxi drop-off data on a satellite image. So we can use this magnifying glass to zoom in, and it updates as we zoom in further and further. And if we zoom in far enough, we can start seeing the individual data points corresponding to taxi drop-offs. We can also use the mouse scroll wheel to zoom out again. Oh, I must have turned it off. There we go. Okay, so but one of the limitations that it's my understanding is not an option with Data Shader, is the hover tool in Bokeh, where I was hovering the cursor over different geometries in a bokeh plot and it would show supplemental metadata. That isn't a capability with Data Shader because it turns everything into a bitmap image. But beyond that, the capability of working with billions of points is difficult to compete with. I'd like to see this kind of capability in 3D, but a lot of data sets lend themselves well enough to 2 dimensions. There's also a good example of pipeline, the Data Shader pipeline, and some interactivity as well. I will go ahead and bring this one up and then call it a day. So let's step through here. So this uses the same, oh, actually it didn't show that HoloView's demonstration, but this, I'll keep going. This is a synthetic data set generated. It's a NumPy array that's just generated 100,000 data points, randomly distributed in sort of a Gaussian distribution. So there's nothing fancy about it, but there's 100,000 data points. It's a bokeh plot here. I can click and drag and it visualizes the way a bokeh plot does. And let's keep stepping through here. So here's an example of HoloViews using Matplotlib as the back end. So there's no interactivity and there's a lot of overplotting, which obscures some of the structure of this data set. You can see in the left-hand plot, there's really 4 distinct clusters, but in the right-hand side, you can't really make out that there is a much smaller cluster in the upper right-hand corner. With HoloViews and Data Shader and Bokeh, at least, then you've got the capability of being able to zoom in and more clearly differentiate those different clusters. And we can also use a feature called Spread, which aggregates the clusters in a more complex interactive visualization. And then I think this is an example of where you can actually turn the data sets on and off. Oh, no, it doesn't look like they're turning on and off. Bokeh does provide the capability of turning subsets on and off with the legend, but it's not doing what I expected it to do there. And okay, I stand corrected. This I must have missed this. There is some hover capability. I'm not sure it's actually, no, it is actually, it's counting the data points in the data set. Okay, so live and learn, there is some hover capabilities. And then, okay, so the last thing I wanted to show you, somebody asked about 3D. HoloViews with Plotly does support some nice interactive 3D visualizations. Okay, so here's an example. I can click and drag and rotate. I can zoom in and zoom out. And with the mouse, it's actually defining cross sections, slices where it's calling out the XYZ coordinates of where I'm hovering my mouse over the surface. And that's with using the Plotly extension in HoloViews. Oh yeah, so I should mention there are some other things that needed to be installed to make sure you can run all these things. Plotly is one of them. And then in the Seaborn examples, you'll also need to be able to install SQL Alchemy and Seaborn itself. So I think I'm gonna end it there. So I think I'm probably getting a little deeper into data shader than I even had time to familiarize myself with. So I'll leave it there. I encourage you to do some exploring yourself. And if there's any questions, I'd be happy to take them. Oh, my cat has a question. So yeah, if there's no more questions, thanks very much, everyone. I really appreciate you joining in. Have a great rest of your day and a great weekend. Thank you, Mary.
Thank you, Jeff. This has been very informative. I'm very eager to do some work where I need to do some plotting and analysis. So thank you very much. And anybody else have a question?
Sorry, I do have a question. I was just having trouble unmuting myself.
Great.
Jeff, do you know if people have used all these graphic things to illustrate the quantum processes just for teaching purpose, for example, never mind about exploring research?
Off the top of my head, I don't. I would be surprised if we couldn't find something fairly easily. Either, you know, the galleries that are available in the different repositories might have something, but no, off the top of my head, I can't think of anything that I'm aware of.
Because that could make it very lively for teaching purposes.
Yeah, I think Andy Getz might be doing some of that. And he's doing, is he doing our next webinar? But we can reach out to him.
He is. He's doing one on GPUs and yeah, you know, atomic orbitals and that sort of thing. I could see that lending itself fairly well.
Yeah, no, but you can also do these two-slit experiments, for example,
For
really in real time, so that the kids can see it, and then you can see the buildup of the inferences with your dots. You know, that's a very powerful tool.
Right, that is a really great idea. I can imagine what you're describing. If you're looking at the two-slit diffraction pattern and changing as the slit separation changes.
Yeah, because you need to convince them this is a process where you have to do you know, thousands and maybe tens, 100,000 photons going back, which means your, you know, 100,000 data points.
That's right.
Then it became like something you recognize.
Yeah, and I'm going to have to go back because I was saying that the hover feature wasn't working. So I'll have to look at how they were pulling off that hover feature, because if it's a bitmap image, the way they're describing data shader working, I don't know how the hover can pick up data.
Yeah.
So I'll have to,
in fact, the 2D plus the temporal, you don't have to further develop it. That's just what it's needed.
That's right. That's a really nice capability.
Yeah, thank you.
You're welcome.
Good comment.
Yeah.
Down the road, that might make an interesting expanse training tutorial. So we can make a note of that.
Right. Yeah, I don't know if there's a role in it for some of the machine learning stuff that we'll be working on, but I can imagine there might be. Interactive graphs or something like that.
Right. Okay. I think I'll stop the recording at this point. I want to thank everybody who made it to this last HPC user training series event. And I hope this has been helpful for you guys, and over time you get some value. Again, we'll be sending out a poll next week asking for feedback, and we'd appreciate it. With that, I'll stop recording.